Hello everyone. In this video we'll learn how to sketch the graph of a function by using the derivative. Now we have seen previously that the sign of the derivative provides us with information about where a function is increasing, decreasing, or stationary. We now will look at the direction of bending of the graph, whether the graph is going to be concave up or concave down. Well, when it comes to the concavity, in general, regardless of the sign of the slope, positive, negative, or zero, the slope of the tangent are decreasing as we move from left to right, or increasing as we are moving from left to right as well. So look at this case here. By looking at the tangent line, which is the one that's in red, we notice that the slope is increasing. So it was here, then here, and if we move on, it will become like this one. So since the derivative is increasing, then that's going to be concave up. Graphically, if I draw the tangent will be below the graph of the function. So if I have a function like this and I want to draw the tangent, it will be below the function or the graph of the function. Now when it comes to the concave down, the slope is decreasing as we move from left to right. So as you notice, it will start here, and when we move on, it will keep decreasing. And if you notice, the tangent line is above the function. So one more time, if I draw something like this, and if I draw a tangent line here, you notice that the tangent line is below the function or the graph of the function. So this is concave up. And if I draw a tangent here and here, you will notice it is above the graph, so it is concave down. So when the second derivative is positive, then the function is concave up. If it is negative, then it's concave down. Now, the change on the concavity from being concave up and then down, or down and then up, the point at which the function changes its concavity is called an inflection point. So here was concave down and then up, up and then down, up and then down. And at that point, the derivative is going to be either zero or does not exist. Very similar to the critical point, but the critical point is basically related to the first derivative, where the point inflection point is related to the second derivative. So now we are going to sketch the function by using the derivative. First of all, in order to sketch the function, we need to know the critical points, increasing and decreasing intervals, any extreme values. That's the first part. And all of these things are related to the first derivative. So, first step, we're going to find the first derivative and study everything related to that. So, f prime of x equal 4x cubed minus 12x squared. In order to find the critical points, we need to make this equal to 0. Factor it. So it's either x equals 0 or x equals 3. These two are critical points. Okay, so these are critical points. So if you want to find f0, it's going to be 10. f3, you can substitute it here, right? Will be negative 17. So I do have critical points at 0, 10, and 3, negative 17. Now I need to study the sign to see the increasing and decreasing intervals. So I can take 0 here and 3 here. Take any points to the right of to the left of 0, between 0 and 3, to the right of 3, and study the sign of f prime of x. So by substituting any point here, you can try -2, substitute it in the f prime, you're gonna get negative. Between 0 to 3, you can take 1. F prime of 1 will be positive, negative again. And anything to the right of 3, you can take 5, 6, 10, 100. F prime of that number will be positive. What does that mean? The function was decreasing all the way till 3 and then increases. So now you need to say function is increasing. So f of x is increasing over the, let's start with decreasing first because we are studying from left to right. So f of x decreasing from -infinity to 0, and then 0 to 3. Remember, you cannot include the critical points. F of x increasing from 3 to infinity. Now, what about the extreme values? Well, as you notice, this is a critical in which the function changed its direction, was decreasing and then increases. So this is going to be an extreme value. Now it's an absolute minima because the function was going all the way from up and then turns up, nothing below this point, which is a 3. So I have an absolute minima at 3, -17. So that's all about the first derivative. Now we will move on to the second derivative. Now I need to find the second derivative. Make it equal to 0 to find the inflection points now. So I'm going to factor it. So it's either x equals 0 or x equal 2. Now inflection points are 0, and then you can find f0, which is 10, the same point where inflection point and critical point, and 2, and if you substitute in the function here, you will get -6. So 2 and -6 were inflection points. Now you are gonna study the sign to find the concavity. Now if you take any point to the left side of 0, and you substitute it in f double prime this time, so we're doing f double prime this time, okay? You take, for example, -1, substitute f double prime of -1, you will get positive. 0 to 2, you can take 1, so to find f double prime of 1, you get negative. You can try anything after 2, like 5, 10, 100, and you substitute it in f double prime, you will get positive. So what does that mean? If the second derivative is positive, then the function was concave up. If it is negative, concave down, concave up. So let's write it here. So fx concave up, where? From -infinity to 0 and 2 to infinity. And it is concave down, basically from 0 to 2. Okay, so now we study the increasing, decreasing, concavity, and all of these things. Let's put things together now. I'm going to draw the number line again, but this time I'm going to put the critical points and the inflection points together, and the first derivative, the second derivative here. So what's happening here? Okay, so when it comes to the concavity, I'm gonna just do it this. Okay, below 0, if you remember, below 0 it was concave up, 0 to 2 was concave down, and then above 2 it was concave up, so it was concave up here. Now when it comes to the first derivative, the function was decreasing all the way from 0 to 3, so it is decreasing, 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 and then increases, right? So that's what we are going to draw. And then we need to remember the critical points and the inflection points. So I'm talking about 0, 10, 3, and negative 17, and then I'm talking about 2 and negative 6. If you remember, this is going to be critical point, inflection point, and again critical and inflection point. Okay, so now let's put all of these information together. So again, 3, negative 17 somewhere here, make it a bit down, and yeah, so I know that this is here, it's gonna be this function, and I'm gonna crawl, okay, go up because it's increasing. Now in this point the function was concave up, and then it's down, okay, and then I'm gonna grow, and then here it's concave down and up. Here we go, okay, kind of, and just see. Okay, now let's try this question here. This is a rational function, 5x plus 1 over x minus 1, and again we are going to follow the same things we have done before. Find f prime of x, and you know it's going to be u prime v minus uv prime over v squared, so it's going to be 5 and when you simplify it, it will be equal to negative 6 over x minus 1 squared. Now you will make it equal to 0, so negative 6 over x minus 1 squared equal to 0. When you cross multiply, it will be negative 6 equals 0. That's an error. So what does that mean? So that means there is no points in which the derivative of the function equal to 0. So there's no critical point, not really sure, because there's critical points not only when the first derivative equal to 0, but also if it does not exist. Now the derivative does not exist at x equal to 1. X cannot be equal to 1 because here you will have a vertical asymptote. Function is undefined at that point, then the derivative does not exist. So I do have a critical point. But at that point, the derivative f prime does not exist. F prime of 1 does not exist. So we know that the derivative does not exist at that point, and it's a critical point. Now we can study the sign at this point. I like to make it as a dot line because I want to remember always that this is a vertical asymptote. Studying the sign of f prime before 1 and to the right side of 1. You can take 0, and if you study it you will get negative, so the function is decreasing. And then after 1 you can try 3, 4, substitute it in here, and you will get also negative, so the function again is decreasing. So the function f decreases all over the domain. It's from negative infinity to 1 and 1 to infinity, or you can say all real numbers but not 1. Fx, there's no increasing intervals, so no increasing intervals. Okay, so that's about the increasing and the derivative in the first derivative. Okay, now So let's find now the second derivative. So f prime of x was negative 6 over x minus 1 squared. I need to find the second derivative. And again, you can do it. I'm gonna write the final answer. It's gonna be 12 over x minus 1 to the power of 3. You can try it yourself. And then I need to make it equal to 0. So 12 over x minus 1 to the power of 3 equals 0. And again, when you cross multiply, you will find that f double prime of x equal to 0. There is none. No points that can give you f double prime equal to 0. However, we're going to also study the sign from the vertical asymptote. Okay? Because again, f double prime at 1 does not exist. So studying the sign at 1, f double prime. So you can substitute, let's say 0 here. You will get a negative answer. So that means concave down. And from the right side, you will get positive, so concave up. Now, if we put all, so we can say function of x concave up. Let's say down first. From I like to take it from left, negative infinity to 1, and concave up from 1 to infinity. Now, let's put all of these things together. Okay, so we did not, by the way, we didn't talk about the maxima and minima. There's no maxima and minima. Remember, function was decreasing the whole time, so there's no extreme values. Now, if I put all of this together, I do have 1 here, and I know it's a vertical asymptote. So I need to study f prime and f double prime sign. Now, if you remember, the function was decreasing the whole time. However, it was concave down here and then concave up. So we're going to go here, draw a vertical asymptote at 1. Now, I know that the function was decreasing and concave down, so it could be something like this, and then decreasing again, but concave up. So decreasing and concave up look like something like this. So it is decreasing but concave up, decreasing but concave down. Okay, I need to find something else to help me here. So I need to find Y-intercept and X intercepts basically. So to help me, at least Y-intercept. Y-intercept is basically when the function equal to 0, and if you substitute f0, you will get negative 1. So I know 0, negative 1 is going to be my Y-intercept. Also, by looking at this function here, we notice that we have a horizontal asymptote, because the degree of the numerator is equal to the degree of the denominator. So horizontal asymptote will be at y equal leading coefficient over leading coefficient. So remember, this is called a leading coefficient, this is called a leading coefficient. 5 over 1 is 5. So I know at y equal 5, I do have a horizontal asymptote, y equal 5. This is x equal 1, a vertical asymptote. I can now draw it. So I can say the function was going closer to the asymptote, but will never cross it. And it is concave down and decreasing. So here we go. That's the first part. Second part, the function was concave up, but decreasing. And it goes closer to the asymptote. So it's going to be something like this. And here we go, done. Okay. Now, you can tell the x-intercepts basically, I just want to say that. X-intercept, basically when the function equal to 0, if fx equals 0. And when you make fx equal to 0, you can say 5x plus 1, x minus 1 equal to 0. Solve it, you will get x equal negative 1 over 5. So if you want to be more accurate, you can say this is negative 1 over 5 and this is negative 1, and you match between them. Okay. So now, what about this question here? So first of all, we will find the first derivative to tell the critical points increasing and decreasing. And I'm going to write the final answer basically. So it's going to be x squared minus 4x plus 1 over x minus 2 squared. Making this equal to 0 to find the critical points. And we cross multiply, you will get x squared minus 4x plus 1 equal to 0. And then if you put this in the calculator, or if you use the quadratic formula, you will get x equals 0.3 and x equals 3.7. So at 0.3, these are critical points. So at 0.3, and if you substitute in the function here, you will get 0.5 and 3.7 with 7.5. So the f3.7 is 7.5. Now you need to study the sign. So I'm going to study it here, or I can do it here. So at 0.3 and 3.7. If you study the sign before, within, and after, you will you need to study the signs for the f prime of x. However, I forgot something here, which is the vertical asymptote, most important. X cannot be equal to 2. So I need to include 2. Where is 2? 2 is going to be somewhere here. Okay, so let me just draw this again. So 0.3, 3.7, and 2. Now we will study the sign before 0.3. You can take try 0. You will get positive. Between 0.3 and 2, negative. 2 and 3.7, negative, and then positive. So that means the function was increasing and then decreases. Yeah, here I have a vertical asymptote. Remember, it's not okay. The function is undefined at this point. Then decreasing again and then increasing. So I have an extreme value here and here. Okay, so fx is increasing, or yeah, from negative infinity to 0.3 and 3.7 to infinity, where it is decreasing from 0.3 to 2 and 2 to 3.7. Okay, now I do have extreme values, and basically since the function is growing, so this is going to be a local maxima, and since the function was coming from down, so this is a local minima. So local max at 0.3 and 0.5, local minima at 3.7, 7.5. Okay. Now let's move on to f double prime. So if you try to calculate f double prime, you will get 6 over x minus 2 cubed. You can do it yourself, and then make it equal to 0, So 6 over x minus 2 cubed equal to 0. When you cross multiply, then there is no value that will make f double prime equal to 0. So if you study the concavity before 2 and after 2, you will get this is negative and this is positive. Again, we are doing f double prime, concave down, concave up. So concave down from negative infinity to 2, concave up from 2 to infinity. Okay, so now let's put all of these things together. So I'm going to have 0.3, 2, and 3.7. And remember, this is a vertical asymptote. F prime, F double prime. So a function was increasing here, decreasing, decreasing, and increasing. Concave down all the way to 2 and up after 2. Now I need to tell, I remember I have vertical asymptote at x equal 2. I have extreme local max at 0.3, 0.5, local minima at 3.7, 7.5. I need to find y-intercept. That's f0, which is going to be basically, if you substitute by 0, you will get 0 and 0.5. And I need to find also x-intercept by making the equation equal to 0. That's going to be positive and 1, 0, and negative 1 and 0. Make this equal to 0. Finally, I need to tell whether I have a horizontal asymptote or oblique asymptote. Well, since the degree of the numerator is greater than the degree of the denominator, then I will have an oblique asymptote. I need to find the equation of the oblique asymptote by the long division. So I'm gonna try to do a long division here. X squared minus 1, and I have a missing 0x, divided by x minus 2. So x squared divided by x is x squared minus 2x. Then you change the signs, you cross these two, so it's going to be 2x minus 1. 2x divided by x is 2, 2x minus 4, that's going to be 3. So whatever you got here is going to be your oblique asymptote. So I do have an oblique asymptote at y equal x plus 2. Now let's try to draw it. So first of all, vertical asymptote at x equal to that's x equal to oblique asymptote at y equal x plus 2. So let's draw this line, x plus 2. So if x is 0, I'll get 2. So 0, 2 is going to be here. And let's make this 1. Let's make x 1. 1 plus 2 is a 3. So 1 and 3. And I will match between these points. That's going to be my oblique asymptote. I can make it negative 2 here. Okay. So these are my asymptotes, okay? Oblique, and I'm going to extend these two lines. Okay. Now these are my asymptotes. Let me find 0.3 and 0.5. It will be somewhere here. Oh no, sorry, my bad. First of all, 0 and 0.5. 0 and 0.5 is going to be here. And then the x-intercept 1, 0, negative 1 and 0. Now you can match between these points. Now if you think about 3.7 and 0.3. Yeah. Here we go. This is the first part. Second part, I do have a 3.7 kind of here, 7.5 somewhere here, 7.5 somewhere here. We're talking about this point here. I know the function is changing its concavity, so it was concave up, and then basically it's all up. It's concave up all the way. So before that it was concave down anyway. Here we go, that's concave up. Okay, now last question. Let's find the derivative, first derivative. Make it equal to 0. So it's x equals 0. X squared minus 1 equal to 0. That means x equal positive or negative 1. So I do have 3 points here. 0. So if I substitute, it will be 0, 1. 1 and 0. And negative 1 and 0. So these are my critical points. Study the sign of f prime. You are going to get negative, positive, negative, positive, decreasing, increasing, decreasing, increasing. So you will say fx is increasing from negative 1, 0 and 1 infinity, decreasing negative infinity, negative 1, 0, 1. Now what about the extreme values? I do have an extreme value here, here, and here. Function was coming from up and then touch this point here and go up. So what happened? Nothing below these 2 points. So these are absolute values. Since they are equal, so at negative 1 and 1, the value was 0. So these are absolute minimum at negative 1, 0, and 1, 0. However, this point here is local max at 0, 1. Okay, local maximum. Now let's find the second derivative. So the second derivative will be equal to 12x squared minus 4. Make it equal to 0. Positive or negative? It will be positive. You will take a square root, right? So it's basically going to be positive or negative 1 over square root of 3. Or you can say square root of 3 over 3, but positive and negative sign. So these are inflection points. So if I find the exact value, I could say positive 1 over square root of 3, comma 4 over 9, and negative 1 square root of 3, 4 over 9. You can substitute it in fx. Studying the concavity. Of f double prime, you are going to get positive, negative, positive, concave up, down, up. So concave up from negative infinity to negative 1 over square root of 3 and 1 over square root of 3 comma infinity, where it's concave down at negative 1 over square root of 3, 1 over square root of 3. So now let's put things together. So I do have negative 1, negative 1 over square root of 3, 0, and 1 over square root of 3, and finally let me redo it. Okay, so negative 1 over square root of 3, 0, 1 over square root of 3, and 1. Okay, now f prime of x, f double prime okay. So what happened? Function was decreasing from negative infinity to negative 1. From negative 1 to 0 it was increasing, then decreasing from 0 to 1, so decreasing from 0 to 1, and then increasing after 1. What about the concavity? A function was concave up till negative 1 over 3, and then concave down from negative 1 over 3 and 1 over square root of 3, then concave up again. I need to find y-intercept. That's when x equal to 0, so I have 0, 1, and I want also x intercepts. I have x intercepts. That's when you make this equal to 0, and you will get a 1, 0 basically, and negative 1 and 0, they are going to be also intercepts. So I'm going to go here, intercepts, intercept. What happened basically? Function was decreasing and concave up till negative 1. So decreasing and concave up, and then again continue concave up, but this time is increasing. See, now it starts concaving down from negative 1 over 3. Let me just I'm gonna redo this. I just want to put negative 1 over square root of 3 and 4 over 9 somewhere here, and same with this one. I'm talking about these points. So let me do it again. So it goes here, concave up and then down, and then up and down, and then up. Okay, so here we go. Okay, that's going to be my graph of this function. So we are done, guys. Please let me know if you have any question, and see you in next video. Bye bye.